What is up everyone, and welcome back to another video. Today will be a start of a new series where I will be teaching you some serverless framework and some AWS thingies. So I've been working with the serverless framework for the past couple of months and had to learn some of the AWS services alongside with it, and I've been kind of liking it. I can see the use in it, and I wanted to make this series to supplement my learning and also give back to show someone that is new to this maybe some shortcuts or some useful tips and tricks. So I would suggest going to the website yourself as well, but I'm just going to cover some of the intro pages. First off, we have the introduction, which gives the philosophy of why the serverless framework came to be, like why does it help and solve, and then some of the companies that use it, which are big names. Some of the key highlights that I want to point out is the code and infrastructure all streamlined into one project in a very organized way. It's easy to use, it's language agnostic, so you have all your favorite languages to choose from, and this is the best one for me, is the full life cycle of building, deploying, monitoring, updating, troubleshooting your web applications. That is very powerful. And then the scalability you get along with AWS and the cloud. We have a good plugin system and a vibrant community, which is also always important with these types of things. Next are some of the core concepts. I will be covering this visually in I quickly cover some of the words or the terminology, which are functions and events. This idea of a function being some code that does something, and the event is whatever causes this logic or function to run. This is like the management or the main bare bone concept that serverless framework helps us do. Is we have functions which are AWS Lambda functions, and things like saving a user to the database, processing a file, or performing some scheduled tasks. What are some of the type events that could trigger these functions? Well, that could be an API gateway, like a REST API, your /products with a query string, and then you have your controller or your, in this case, function that runs and connects to the database and fetches products. We have a S3 lifecycle event. So this is even something more complicated than if you had your own setup, right? So you have this almost webhooks with serverless with S3 that can now trigger a Lambda function and optimize the size of an image, or move files from one place to another, or resize them, or transcribe stuff and stuff like that. So this can become very useful and complicated, and just a great way to manage it all through the serverless framework. So those are types of events. Resources are stuff like your databases, your RabbitMQs, or your SNS or SQS, or a bunch of AWS services that sound like a bunch of weird names but are actually stuff. You can set up all of that through the serverless framework, and this important concept, I want that word for you to go and Google if I don't explain it well enough, or just remember this part, is CloudFormation, which is AWS YAML syntax or JSON syntax of describing or setting up services. For example, these mentioned above here, like different resources. So you can use CloudFormation natively within the serverless framework, and the serverless framework is kind of built on top of the CloudFormation because it abstracts away a bunch of stuff that kind of starts seeming repetitive and annoying with CloudFormation. It helps make that less redundant and a lot more maintainable. Okay, and then the idea of services are like the definition of serverless.yaml functions, which you then deploy using the serverless deploy. Yeah, this is just a way of grouping files in a serverless project. Then we have plugins here at the bottom. One of the ones we'll use is the serverless offline, which helps you run AWS Lambda and API gateway stuff locally instead of having to deploy it. So let's dive into the visual part of this core concepts, and then we'll start looking at the project idea. Okay, so in our diagram tool, let's take a look at the visual representation of a project architecture using AWS services. So the serverless framework is mainly used with AWS. Most of the examples are showcasing AWS services. I know it states in the documentation it can be used with other vendors as well. So, but for this tutorial series, we will be using AWS. And AWS has a lot of services it provides, but most of them you will not need, and we will be covering some of the important ones in this series, and we will be using some of these services to showcase the architecture. So let's start with the first service, AWS API Gateway. That's what the short stands for. This basically gives us a RESTful API. So we have the /products with a query string, with a post method and a get and a put and a delete. We have this ability to set up endpoints that trigger specific functions. And these functions can run in any programming language, and in a serverless fashion, it can run on AWS Lambda. So now we have this type of setup where AWS API Gateway has some endpoints that connect and trigger some function with some logic. And let's say that function would like to connect to the database. Then we have AWS RDS service running with a PostgreSQL database. So this is pretty much just a managed database from AWS. There are multiple different database types you can use. And then this Lambda can connect and talk to this Postgres database through its connection string, just like you would do with a normal database set up in a project. Then we can add more services and just grow this architecture where we have this AWS bucket, S3 bucket that handles files, so we can upload images or video files or just normal storage JSON files. And we can trigger AWS Lambda functions based off of lifecycles. So whenever a new file, or in S3 terms, whenever a new object gets created, we can trigger some or set up some triggers that calls a Lambda to resize this image or add this image string to the database, or just do some logic with that image at the end of the day. Then we also have this ability to set up caching for Redis and Elasticsearch and a bunch of other services to make our architecture even more robust or scalable. And we can do this whole type of setup with Serverless Framework in a very neat and organized way, because like you can see, there are some stuff that needs to be interconnected with each other in a secure way, and AWS has this concept of IAM rules, identity access management, where you have roles that you can assign this Lambda to connect to this database and so forth to the rest of the other services. And Serverless Framework handles a lot of that under the hood for us. So it kind of does this setup between AWS Lambda and AWS Gateway in a very smooth way, and this connection between some lifecycle event to AWS Lambda in a very, very clean way. And then this Lambda will use the AWS SDK for its specific language, and it will connect to these different services, whether it's S3 or database or caching. So for our server that we're going to build, we're not going to have a cache, so we can remove that service, and we're going to be using DynamoDB, which is the NoSQL database of Amazon, to build our API. And our API will have a few endpoints. We will have a post books endpoint. So let's just build a basic book API. So we'll have this type of project set up. This API will be pretty simple, but it's going to showcase you how we can set up a basic API like this, which can become very complicated at some point. You can have a bunch of different endpoints and a bunch of different services to make this application scalable. And then, yeah, this is going to be the idea. We will be able to upload images when we upload a book or update a book. So this will have like a image connected to the book, and we will use Lambda to handle this, saving to DynamoDB and optimizing the image with Sharp package. So yeah, this will be the architecture, and let's actually start in the next video where we will start setting up the project. Another important page before we get started is setting up the serverless framework CLI on our local machine. And once again, under the getting started setup, there are a few steps we can go through here, and it pretty much is a useful guide to explain what are we setting up. Okay, so let's I don't have this set up on my machine, so I'm actually just going to follow these steps directly, and this is going to be almost like a live me trying to do the setup. We don't have it installed yet. Let's go to our terminal and let's paste that in. Paste that incorrectly. Okay, so now I first need to make sure what node version am I running. Okay, so that's fine. I can install this, and now we should have serverless as a CLI tool installed. Okay, so I'm running that. Looks like it's loading, downloading serverless framework. Okay, so I just ran that again, and now it gives us these options to set up like different projects to start with. So we have Express API, Expressive DynamoDB, and a bunch of other stuff. I'm not going to choose a starter template from here. I'm going to create one without using the CLI, just to keep it simple. Well, let's see if they give examples here. So this is to update it. So what version are we running now? Serverless version. Okay, we are running the new version 4, which is cool. Also my first time using that one. And now we can use the serverless command to check if serverless credentials are set up. So that is regarding AWS credentials. And as a prerequisite for this video series, I would suggest go set up an AWS account. There's a way to set up free tier. It's pretty easy. Just follow the sign up steps for AWS console. And then once you're able to log into your AWS dashboard, then you can come back and you can finalize the setup, which according to this tool seems pretty easy. It actually would prompt you with the required steps to sign in. Here we can create the concept of an app. Here's the setting up AWS credentials. So it would actually prompt you that your environment machine does not have the correct AWS variables set up. And yeah, so to give you an idea of where you should go for that, inside of your root directory, there's a .aws folder, and there's usually, if we ls that, there's a file called credentials, and yeah, under that credentials you'll add your required AWS keys, and then serverless framework automatically detects those keys from there. So if you follow the CLI steps, it would probably take you through that same steps, and here is a guide that has more detail on that. We will use the serverless CLI to ultimately deploy all of our CloudFormation, and we can use the serverless CLI to invoke functions locally. So this is pretty cool. We don't need to have an API gateway trigger. We can trigger the code through the CLI itself. We can stream logs, and there's a full local development. This is new to version 4, where we can run it like this with a dev flag. I believe it was up here. Yes, serverless dev, and this kind of streams it to your machine. It like does a proxy to your machine's code, so you don't have to like redeploy all the time. and then you can see the logs directly in that session as well. So we will kind of cover all of these, or most of them, as we go ahead, but definitely have a look at this page just to set up your connection between the serverless framework and your AWS account, because at the end of the day, serverless framework will ultimately deploy stuff to your AWS account through the CLI. Okay, so yeah, get that done. And once we have serverless framework CLI installed, we can go ahead and set up our project. Okay, so now that we have our AWS dashboard logged in, here I'm logged into my AWS dashboard, and hopefully you were able to set up your account on AWS and follow the steps to set up your local computer to have the AWS config required for the serverless framework. So I do suggest, if you have not done that yet, go ahead and follow the documentation in the serverless project. But basically you should have if I were to ls this, there should be a credentials file under your .aws directory of your machine, which should contain your key and secret for AWS. And if that is set up correctly, we can start by setting up our serverless project. So if you remember from our diagram, this is the setup we want. So we want AWS Lambda with AWS Gateway, and then we want these endpoints. So in order to do this, let's first set up npm package using yarn or npm, whatever. And then we want to install Typescript. So we can say yarn add, and as a developer, Typescript. Okay, and then you want to say yarn tc init, and it should be like this. Okay, now we've created a tsconfig. I'm just going to remove all of this. Okay, so these are some of the basic stuff required. So let's make this ES6, and modules should be ES6, and these are all true, strict. Yeah, let's keep that going. And we want to set the root directory to be /app. So we will create an app directory, and this could be anything, right? I'm just calling it app because that's how I kind of got used to it now. So I'm gonna make their app, and then in that directory I'm gonna create another one called handlers, and in here all of our functions for our application would go in. And then we need to create the important file, the serverless.yaml. So this is where it all starts. And if you are a VS Code user, I suggest these two plugins, Serverless Framework and Serverless IDE. They just give some autocomplete. So to start the Serverless Framework service, we can run this init, which prompts us with all the required initial fields. So we're going to call this book API, and we want to run Node.js version 20. And our stage will just always be develop, and our region we can set to EU Central 1. So the rest are just some defaults for the Lambda memory size and the Lambda timeout. So these regions, you can find them all in the AWS console. There are a bunch of regions, and you can see these string prefixes on the side. So I'm choosing EU Central 1 as that's closest to me. And yeah, now we have a basic serverless service running, but there's no functions or no resources connected to it yet. So let's actually go ahead and create our first function. And we do this by specifying the functions keyword, and then we can say SLS function, which creates a new function definition for us. So we can look at some of these important fields. The first one is the internal logical name. So in the serverless framework, we will reference this function by means of this name. So we can say get books, and this handler, where is the handler of this function? So this would be in the app handlers. So we can say app handlers slash, and then we're going to call this get book. And then there will be a function in the getBooks file called or exported as handler. So the description will be get all books from DB. And the runtime, we will just have a default to the one up here. Same for the memory and timeout. And then what events will trigger this handler, okay? So there is quite a few events that we can choose from, and we'll explore some of them later, but for now this will just be a normal HTTP event which will create a REST endpoint on API gateway with some properties we can specify. So we can say books, and the endpoint method is a get, and we don't worry about the cores and the private field for now. So now we have our first function, but we haven't created that function file yet. So let's actually go ahead and do that and say get books.ts, and in here we export async function called handler that takes in an event, because Lambda functions can be triggered by multiple things, and this event will ultimately tell us more information about what caused this event to toggle. So let's actually console log out this event, and I'm just going to call it event URL, and we can say, I'm not sure what this was called, but let's for now just log out the event. Okay, and then here we can return object, which for API gateway response we need to have a body which should have a string, so we can just stringify this object that has foo bar, and we need a status code of any HTTP status code. So let's just make it 200, and this event will have an implicit type of any. So let's just keep it as any for now. And now we want to test out this function, right? So how do we actually deploy this to AWS and get it live and working? Okay, so very easy. If you have everything set up correctly, we should just be able to say SLS deploy and hands in the air. Everything else should deploy without us doing anything. So here we can see it's deploying the book API, which is the name of our service, and it's deploying to the stage of develop and this region, which is pretty powerful already. We are deploying to a live environment that already has all the important security stuff and the right environments based on our settings, and yeah, it's pretty powerful. And you'll see as we start developing more and more how easy it is to get changes live, and yeah, it's just very powerful. So let's wait for this CloudFormation to deploy, and then we can explore some of the other commands to maybe deploy only one function at a time, which is a lot quicker than redeploying the entire service stack, especially as this stack or this service becomes bigger and bigger. Okay, so here we can see some output from the serverless framework. We now have one endpoint with HTTPS endpoint /dev/books. So now if I were to make this call, I'm just going to use curl down here to this endpoint. We see a JSON response of foo bar. So this is exactly what we have responded with over here. And we should see some console log event. So in serverless, we can check the logs by either going to the AWS console, or we can say SLS logs and then the function name, which is the logical name, which is get books, and we want to tail it. So now we can see streaming new logs from this function, and I'm going to open a new terminal and then just calling let's say new URL, we should see a log firing off on the side, which should log out this event, which is a very big like HTTP gateway event. So here we can see a bunch of stuff on this event. So we can see the method path, the resource, some helper headers, and yeah, at some point we can add authentication and destructure from the identity, the user, and if we have body data, we'll see that here. So very powerful stuff thus far. We have logging and monitoring already set up for this endpoint, and we pretty much just hit serverless deploy. So let's actually speed this up and create all of the other endpoints. It's going to be quick, so I'm just going to copy this one down. This will become the create of a book, and it will go to create book handler function, which will create new book on DB, in DB, probably in DB, and this will be post. Okay, so there we have another endpoint. So let's just add some space in between. So now we want to get a book by ID. So we can say get book by ID, and this will be get a book in DB by ID. And the path will just look a little bit different. We will now have this query or this path parameter, and we will name it book ID. And this will be the logical ID that's used in code to get this value as well. And this will be a get. So now we can do the same thing for update, which would be update the book, and this would change to update the book, and this would be a put request, and here we can say delete. We're gonna delete this book, delete this book by ID, and this will be a delete request. Okay, so now in the serverless we have defined everything we needed with all of its events, and in the background it will go ahead and create all of these endpoints with their API gateway setups for us. Now we just need to create the endpoints for get book by ID.ts, and yeah, let's just copy and paste that in here. So it will be the event foo bar. Let's just call this method get book by ID, and this will just be method get books. Okay, so this is not very useful Lambda functions, but for now this would work. Okay, so let's create the update book by ID, and then we have this one, which would be the delete book by ID, and then we have the create book. Okay, so it's the get book by ID, update book by ID, delete book by ID, and create book. Okay, so this would be create book. Okay, this would be delete book. This would be update book, get books, and get book by ID. Okay, so now we have functions for all of them. They return with some special message just to identify them for now. And all we need to do now is say SLS deploy and let the magic happen. So just to quickly show you on this side, when I go to my account under this same region, I can see there is a dev books API with only one API endpoint on API gateway. And as soon as this deployment here is done, so I can actually close off this terminal for now. As soon as this CloudFormation stack is deployed, after all the changes we've made here, we should see an update here with all of the other endpoints. And it was so quick, and it's already live. And yeah, now you can just continue working with the serverless framework. And here we can see all the updated endpoints, the functions and the endpoints we can see are logged out pretty nicely for us over here. So now I'm going to open my client. I'm just going to copy this base URL, set it up like this, /books. Okay, so let's get the books. Okay, run this one. We see get books. Now we want to post a new book. So let's post a book. So we created a new book. So let's put to that specific ID. We update the book. Now we want to delete the book with that specific ID. We delete the book. And now we want to get a book by that specific ID. And we send and we get the book. So now we have all these endpoints and their API gateway associated stuff live. And I would encourage you to go to the console and then kind of inspect what did the serverless framework do in the background. So it created /books and then a /books/ID, and then it kind of groups the different methods. And you can go into them and take a look at some of the settings regarding that. You can inspect the Lambda function that's associated with that endpoint, and you can view some monitoring about the invocations of this function, and you can go to CloudWatch and you can see even more details. So here we can see log groups that were created, and our console log. Here we can see our console logs that we have in code that's getting logged here, and these logs are searchable and they are available for, I think by default, 14 days. So you have like everything set up instantly by just this few lines of code. So this is pretty impressive, and this is the part that we're going to get into even more as this project continues, as we set up a database and start doing some logic with file uploads and communicating between the different services. So this is all for this video. In the next video we will start adding some logic and maybe start looking at adding the database part, and that's it. Okay, so now that we have our functions and our endpoints deployed to AWS by just running the serverless deploy command, which is pretty easy, and we saw them live in AWS console. So let's switch back there again. So I'm gonna head over to the home and I'm gonna click on API gateway, and here I can see our different APIs, and one of them is our book API. And under the book API, I can see all the endpoints that were generated in API Gateway. And if I click on them, I can also go to the functions that link to this endpoint. So let's go and view that in the Lambda service. So that's another service that we've touched. And we can click on applications on the side, and then we can select our book API project. Underneath here, we can see a bunch of the resources that it used or created. So we have a Lambda function, we have a Lambda function, Lambda function, Lambda function, and then we see a bunch of other stuff here as well. So one is the API Gateway REST API. So we just took a look at that one, and all these got linked together automatically by the serverless framework. And then we have this concept of log groups for each individual Lambda function, which is great because it makes debugging and inspecting some logs very easy, and you get it set up right off the bat. Then again, each of the Lambda functions has a log group, and then ultimately we see something S3 here, and basically this S3 is all our Lambda functions. So this TypeScript code that we wrote to handle some event, that gets bundled to JavaScript by the serverless framework. It gets put into a zip file and it gets deployed to this bucket. And then in the background, the Lambda functions get deployed from this bucket. So it's like keeping its own repository of the code in S3 as well. So in the background, the serverless framework spins this up for us as well. And then again, we have our Lambda function and log group. We can explore some of the other functions as well, or services as well, and that's S3. So we can take a look at this bucket. So I'm just going to I'm just going to search for the book API bucket, and we can see this is the serverless deployment bucket with some ID, and it's in the same location that we set up, and we can do some other stuff there as well. And then in here we can navigate to the directories. Here we can see the dev folder with some timestamp, and then we see the deployed code. So this zip file, if we were to download that, we would be able to see all of our JavaScript code in there. That is just some insights into what all of this code has done for us. Now another nice command that we can use to actually delete all of these resources that was just spun up, we can just say sls remove. And once again, hands in the air, and we just watch the serverless framework do its magic by going through this file and then in logical order deleting and removing all the required resources that was created. So now we've been to the S3 bucket over here. So let's actually stay there, and as soon as this remove is done, we'll go and inspect, and we'll be able to see, okay, that was quick. So it removed all of the services. And now if I were to go here and refresh again, we don't have any bucket with the book API anymore. And if we go to our API gateway and have a look at our APIs, we no longer have the book API anymore. And the same goes for the serverless functions. So if we look at the applications, we don't see our book API application anymore. Hence, all of our serverless functions got removed as well. So that was quite quick and quite easy. And to deploy it again, we just say serverless deploy, and it does all of the magic again. So it's very quick, and we get a lot of advantage from the serverless framework, as you can see. So in the next part of the videos, we will start talking about our code setup and how we will structure our code so that it makes sense and is scalable. And yeah, a bunch to learn more. So I hope you're excited and stay tuned. Okay, so now we're going to take a look at some code structure. Our code base is going to grow in size. We're going to interact with multiple services, and there's going to be some reusable logic or logic that we want to group together. And how do we do that in a scalable and proven way? Well, one of the ways that I've been taught or been exposed to in the last few months is been dependency injection. So let's look at a quick simple definition. Dependency injection is a programming technique that makes a class independent of its dependencies. It achieves this by decoupling the use of an object from its creation. This helps you to allow solid dependencies, inversion, and single responsibility principle. Okay, so that's quite a mouthful, but the stuff to ultimately take out of this is it basically helps us decouple code in such a way that it's very scalable and organized. So we are going to follow the following structure. We are going to have our handlers, and like you probably saw in the definition, it mentioned the word class. So we're going to be using some sort of a class-based system, which is also very organized. And yeah, don't run away. You can do it in any other way. You can just use basic functions and not go with the class-based syntax, which is also fine. But for this video series, we will be using classes. Okay, so we're going to have a three-layer architecture. We're going to have our handlers, which is the current folder that I'm in now. And this handler is going to talk to a model, and this model will talk to a repository. Okay, so we will inject our handler with our model, and our model will be injected with the repository. So this is where this whole dependency injection part comes into play. And I'm gonna explain it only for the create books, and the rest I'll kind of time lapse through because they'll be exactly the same, and I'm not gonna re-explain that, so I'm gonna take time to explain the create books and how we can refactor it to this type of setup. So first of all, let's go ahead and comment this, and then let's create that handler class. So we're gonna say class, And let's call this create book handler to match with the file name. And if you have a different code, like rules in your code base, you can just consistently follow that as well. And for a class, we will always need a constructor, and ultimately this constructor will create the blueprint of this object, which can be used. So we will have an async method called process event, and this will receive the event, which is also of type any for now. So, and then this event would handle this handler logic. And we still need this export of this function handler. The rest of the grouping of the code starts in this function. So that's why we don't want to do too much logic inside of this handler. We can ultimately just handle our errors inside of the handler for whatever this create books process method can throw at the end of the day. Okay, so in order to still have that same return, we can say return and create a new book handler, and then on that instance we can say process event and pass that in the event that we are getting from the handler call. And to make this a bit more clean, I'm going to move this, or only the first part, to a variable called instance, which pretty much just gives us an instance of this handler. And here we can say instance and then call the process event. Because this is an asynchronous function over here and an asynchronous function over here, this should actually be awaited. So we should say await and then return. And there is a possibility for an error. So I'm just going to wrap this all in a try catch. And here I'm going to console log .error create book handler error, and we can pass that in. And then we need to also do a return, so we can just return with a status code of 500. Let's keep it an internal server error for now because we don't handle different errors at this point. And we also need a body, which should be a string, and we can just add an error something went wrong, check your logs. Okay, so this is very developer friendly, not suggested for production error messages. So this is the first setup. So we have added some error handling, which is also improved, and now we've structured this to a class. So we first have this handler. Now again, before we would actually return this status code, we would go ahead and create this book. So first of all, we will get the body data, and this body data will ultimately come from the event. So we can say event.body, and this will be some JSON string, so we need to parse this as well. So we have no idea how this body data is going to look, so we would need to do some validation here. So we can say validation of body, and we will be using a package called Zod. So now you're going to also see how we can actually add more dependencies to our project, like for example Zod. So we can say yarn add Zod, and now I can import Z from Zod, and let's take a look. Okay, so here we can say Zod.parse, and we want to parse this body object, but we should set this is actually not Zod.parse. We need to create a schema. So at the top here we can say const book schema, which will be equal to a Zod object. Why is Zod not imported here? module. Okay, so some TypeScript setting to node next. Which setting? Module resolution. Node next, and save that. Okay, so this would need to update. The option module must be set to node next when module resolution is set to node next. Okay, so isn't that the case now? Yeah. And our target, we don't, oh, ES next. Okay, so that's a bit more upgraded JS. So here we want to say Zod object, and how do we want this body to look? So for now, let's just say the title, the book has a title, and this title is of type string, and it is required by default. So we can say it's optional by making it optional with this flag, but by default it's required. So now we can use this schema and say this schema dot parse whatever object we get from down here. And if this fails, it would throw all the way until down here. So we're kind of doing the validation of the body data up here. So this is not some extreme validation here, but yeah, let's just keep it simple for now. Okay, so here we have a log to still log the event, which we can inspect. And then we are parsing the event body, which is a string, and then we are validating it. So now we've done all the type of logic I would consider we should do inside of a handler. And we can do a bunch more here because this event can have multiple other types of data that we need. For example, authorization token or headers that we need to fetch some configs for based on. But yeah, now we want to pass this body and the rest of the data that might be needed to the model. And this model will then communicate to the repository, which will add it to the database. So let's go ahead and create the model and repository folders. So in the app, I'm going to create models and repositories. Okay. So for the models, we're going to group all of the book entity logic into one model. So there's only going to be one file called bookmodel.ps, and the same for the repository. There's only going to be one repository called bookrepository.ts. Okay, so now we want the setup. So what are we going to use the model for, and how are we going to use it? So here we want to start send book data to model. Okay, and then in the model, this is also going to be a class. Once again, we can say class book model, which again gets constructor. We'll do some dependency injection in just a second. And then here we want a function called create book. Okay, and this create book gets the book data, which is of type any for now, or we actually do have a type already, which is this book schema. Okay, so we can actually use this as our body data interface by creating an inference from Zod schemas. So we can say we can create, export this type of book schema, book body schema, or just book body. And then we're going to say Zod.infer, which is a generic, and we're going to infer the type of this book schema. So now we have that type, which whenever we update how the schema should look, this body will also be updated. So we can save that, and we will receive the interface of book body here when we create a book. So now this model will do some other stuff. At this point it's not much, but we will also do some asynchronous function, which will return a promise of this point any, and we will return whatever the function is inside of the repository. So here we can create a class, book repository, and again this has a constructor, and we have a function here also called create book, and it receives the book data, which can also be that same interface. And this will also be an asynchronous function because we will ultimately talk to the database at this point. So we will talk to DB at this point. Okay, so how do we now inject all of this functions and logic into this code structure? Okay, so what we're going to do is where we declare the instance, we will have some values in the constructor that's required to be injected. So for this, we will need to inject a model. So we can say we are expecting a private read-only book model instance, which will be of type book model. I don't think we're exporting this class, so we need to export this class. So this is like shorthand, instead of going in here and saying book model is equal to book model, it would be this dot book model is equal to the book model that gets passed in. And you would need to do that for everyone, and you would need to declare a private variable up here called book model and of what type it is. So this is another way of doing that, but instead of doing that syntax, we shorthand it all to just this syntax, which is also pretty clean. Okay, so now we have this book model, but we are not passing it in down here. So we need to go and create a new instance of the book model. Book model instance will be equal to new book model. But instead of having to do it like this, what I like to do is say export a function here called create book model, and this basically just does that new keyword setup for you. And whenever the book model needs other dependencies, we can set it up here, which will be the repository at some point. So this kind of gets set up along the way. Otherwise, you would need to create the repository as well and then inject that. So what we can do is just call this function create book model, and this will return an instance of book model, which we can then add to our class. I know this seems a bit much, but just trust me on it. When the project grows, this becomes very intuitive and very useful. So now we can use the this keyword to get the book model and then call the create book function. And we would like to pass the safe body. So Zod returns this parsed body, and then we have that safe body, which we can safely pass to the create book function, which is an asynchronous function which we should await. And if something were to go wrong inside of the book model would throw its necessary errors, which would then be catched and handled down here, and then it would never get to the status 200 return. Okay, so we're not expecting, okay, maybe we would want to expect the book that we get back. So we can say await the book, and then once we have this book, we can just return the book data. So data would be the book. Okay, so Here we have our setup almost complete. Now we just need to add some logic over here to inject the book repository. So let's go ahead and create the same function here. Create a book repository. And this will again return a new book repository, which then can be used down here where we can say book repository instance. I'm giving them very long names just to make it clear what's happening. And we want to get the create book repository function. And this can be passed into this book model down here. Currently, this constructor is not set up to handle it yet. This is why it's giving an error. So we can again do that same thing where we say private read-only book repository instance, which is of type book repository, which we are not exporting. So we need to export this class of book repository. And then it can be imported here. We just need to save this. Okay, so now here we can say this dot book repository instance dot create book. And again, we need to provide it with the book data. So here we're not awaiting anything. We're just like returning it directly, but we should be able to do some other logic, other mapping or structural logic here. But for this simple use case, we're not doing anything now. So it's just returning directly from the book repository. Inside of the book repository method, we would now ultimately talk to the database, and then we would return the new book. And the new book would be that same information that we need for the book. So we have some ID, let's just call it some ID for now. And then it has a title, and the title would be the body.title that we've provided. And then we would obviously save it here to the database and then return the newly saved entity. So now, all the way up until here, it's going to receive back the book, which is of type any, because our types are still a bit messed up. Let's actually do that now. So our repository will return a book that is saved. So we're just going to call that type book. And how would the book look? It would have a ID string, and it would have a title, which is also of type string. And we can export this type from here. This promise will return a type of book. So you can see if I would not do return ID, it would complain because it's not returning the right type. And then this model will also receive the book type and just return it. So ultimately this handler over here would receive a book type, which would then be returned by the data. So here we have some good setup going with the dependency injection. I'm going to do a time lapse through the rest of the code where I'm not going to do too much talking, and then we're going to ultimately deploy all of this, which is basically going to give us the same output we already have. We just have our structure set up ready to go and start working with our first services that we're going to set up after this, which is DynamoDB database. So enjoy the time lapse. Okay, so now we have all of the repositories and the models and the handlers set up in this dependency injection way. Let's go ahead and deploy this and then test it and see if it works. So SLS deploy, hands back. Okay, so now that is deployed, let's go ahead and test out the endpoints. So I have the endpoints here. I believe this changed since I last updated. Cool. Okay, so now we want to do a get of books, and this should return us data, which is all of our books, which is currently just hard-coded data. And we want to do a post. So let's actually send a body, because if we don't send the body, something went wrong, please check your logs. And if we actually were to do that, check the logs of the function called create book, and we want to tail that. Let's see what it gives us. Here we can see it's creating our log stream. Okay, and if I send this again, we get a 500 error, and we should see the log in a few seconds. Sometimes there is a bit of a delay. And here we can see it's a ZOD object error, invalid types, received null, expected the object. So the body type of our JSON was invalid. So now if we actually were to clear this and send along a JSON body that has the required field of title, and we can say book test and send. Now we get back a data object with an ID and a title of book test. And obviously if you were to add an incorrect field here, some field, here we can see the actual event that was sent. So we can see here the body, the one that just succeeded. We can see the body here in the event, which is a string, a JSON string. That's why we have to JSON parse it. And yeah, that's it. And then now, if I clear this again and I send the incorrect type, it again fails the validation, and there should be a ZOD error log that pops up in just a sec. Okay, here we can see, yeah, we have an issue, expected string undefined, invalid type string undefined. So that's not the clearest error message. Expected a string path title, so there was no title string provided, and it's a required field. So here we just need to say some title, test, and send it, and then we get back our response. And this is the same for the put. We need to provide an ID, and we can send that one. There is that ID. If we update the ID, we can see it updates alongside of it. And if we do a delete, we shouldn't get any response, just a message that says deleted. And getting by ID, again, we can just have a call. What happened here? Error request could not be satisfied. That is too bad. Forbidden. Why would this be a forbidden request? Is it because I have body data? Yeah, looks like because I sent along body data. So you can't do that, interesting fact. And here we can just see, again, it updates based on the ID that we provide. And now we've refactored all of our code into dependency injection, and from here the next videos we'll get into the meat of creating a resource in the serverless framework for our DynamoDB table. Stay tuned. Now that we have our functions set up in the correct coding structure, let's set up our first resource. So how do we set up resources in serverless framework, and what is this resource that we're going to set up? So first, how do we set up resources with serverless framework? Well, it's very easy. We have these three familiar flags: the service key, the provider key, and the functions key. So under the resource property, resources, we can add CloudFormation templates. So here we can see that it mentions that word CloudFormation again, which I emphasized in the beginning. So how do we make, and surprisingly this example gives a DynamoDB table with the properties that we will need. But let's look at this from DynamoDB's documentation point of view. So this is DynamoDB in the console. So I would suggest take a look at this video. This is very marketing orientated, not really development orientated, but there are pretty good videos for developers explaining a lot more in detail from the beginning what DynamoDB is and how it works. All that you need to worry about today is that it's a database, which is a NoSQL database, and it really works with the notion of partition keys and sort keys. And you structure these keys, which are basically just strings, in such a way that they are sortable and searchable based on properties on that string. So it will become clear as soon as we start saving books and querying them. But we can define DynamoDB through CloudFormation. So there's the setup of the database, like different properties, the name, the key schema, like whether you have global secondary indexes and what is the deletion policies and rules like that, right? So for now, I'm not going to dive too deep in these things. I'm just showing you how to use Serverless Framework and in combination the DynamoDB documentation for CloudFormation to set up something with Serverless Framework. Okay, so here's the YAML definition. So our Serverless Framework is in YAML, so we can take a look at this one. And basically all that we need to do is say type of AWS DynamoDB table, and then there's a bunch of properties. Not all of them are mandatory, but I have already set up something in the code base. So let's go back there. Okay, so here I'm going to create that resources property, and then I'm going to paste in some code or some syntax. So this is CloudFormation, and this is pretty much the same that we saw in the documentation of DynamoDB. We have a resource called books table, and it is of type DynamoDB table with a bunch of properties, the table name, the attribute definitions, the key schema. This is almost like setting up a bit of a model in SQLize and other type of stuff. You're defining some properties with these regarding the keys and some searchable fields. Okay, not going to go into much detail with that, but trust me on this, copy and paste this in. And now we want to deploy this table live to DynamoDB, and it's very, very easy. We just say serverless deploy again, and it will read through our resources and our functions and start deploying stuff that's not there already or new or needs to update. So if we go to our dashboard, okay, and we go to the tables page and we do a refresh, we don't see the book table. We did see it there for a moment because I removed it again and deployed it again now. So if we refresh now, we don't see the books table yet, but if we give it a second and do a refresh, okay, so there we can see this finished deploying now. So now if we go back here and we do a refresh, we see the books table popping up here. Okay, so now it has all the settings that we specified and some defaults set for us. In this page, we can view a bunch of things like the indexes, monitoring, global tables, backups, exports and streams, other permissions that we'll get to in just a sec. Additional settings, which is this read-write capacity units and time to live options, encryption, deletion policies. So if I were to remove something from the serverless framework and this already has a bunch of production data, I don't want this to be deleted as well. So you can set up some deletion protection rules as well. I'm not going to get into that now, but we'll do that in some separate video. Okay, so now we have this table deployed. Now I want to be able to interact with this table through my repositories. So I have these functions, creating a book, getting a book, get books, delete book, update book. How do I do this and talk to that DynamoDB table? Well, we're going to be using the AWS SDK, and we will get that installed and set up right after this. Okay, so to get started with these AWS SDKs, we are going to need to install a few packages. So currently we only have Zod installed, so we are still pretty lightweight on the project dependencies. But now we're going to start using the AWS dependencies to talk to DynamoDB. So first, let's install the yarn add the client for DynamoDB. So it's the AWS SDK client DynamoDB. And then we also want the AWS SDK /lib for DynamoDB. And then we want the AWS Lambda installed and the package UUID. So these are a few packages that we're going to be using now. So I'm just going to run this and let it install. So these two DynamoDB packages, I'll get to them in just a second why we need them. And now that that is installed, I want to install one dev dependency for the AWS Lambda package. So we can say -dev, and we want to install the @types for AWS Lambda. Okay, with that all set up, now we can actually go to our book repository and we can start using the SDK. So again, to make our code more maintainable, let's say we want to use this DynamoDB connection setup in a few different places. What I'm going to do is I'm going to create a new folder called clients, and under the clients I create a function file called create DynamoDB client.ts. And all we're going to do here is we're going to set up, according to the DynamoDB documentation for the SDK, we're going to set up the connection through this function so it can be reused. So here we're going to say import from @AWS client. We want to get the DynamoDB client. Oops. And then we can export a default function, and we call this function the same as the file name, create DynamoDB client. And what this is going to do is we're going to create a client with this new DynamoDB client, and we can provide it some properties in here that we're not going to worry about now. And to make working with the DynamoDB SDK easier, we're going to wrap this client with a document client. So that's what the other library is for. So we're going to create DynamoDB document client, and we're going to set this equal to DynamoDB document client, which gets imported from the libs package. And then here we call the from method, and we pass it in just the root client down here. And then we return this DB document client. So this will return a DynamoDB document client, and we can use this to interact with DynamoDB and create queries and stuff like that. So now that we've created this function that basically sets up the SDK to connect with DynamoDB, we can inject that into our book repository. So we can create this client, so DB client. So this can now be any type of database. It doesn't need to be just DynamoDB, but then we can create a DynamoDB client, and we can inject that into our repository. and now our repository should require the DB client. DB client should be equal to the DynamoDB document client. Just like that. Now, in our create book and our get book by ID, we can actually use this .db client to interact with DynamoDB. So let's actually go to the documentation of this SDK so I can show you a bit of what was set up now. And then we can look at some of the methods that we can use to actually interact with creating a book, getting a book by ID, and doing some queries and stuff like that. Okay, so here I've Googled the DynamoDB AWS JS SDK version 3. So if we go to this documentation, we can on the side already see some of the starred services to view is DynamoDB, which I'm going to click on. And then here we can see some information. So first off, we use the same npm package. So we have installed the AWS client and we used yarn. So I believe somewhere here you would get the document client, so DynamoDB client config. And here we can see all of the different commands that we can run with this SDK. I do want to get to the document client documentation. Okay, so here we are at the libDynamoDB package, which we also installed. And basically what this does as an overview here, we can see that this document client simplifies working with items in DynamoDB by abstracting away some of the notation of attribute values. So it would have this type of notation where you have the attribute type and then the values, and then again the attribute types and the values. And this kind of becomes a bit messy to work with, because you find yourself keep mapping between what DynamoDB has and just a normal JSON object. And this document client pretty much does exactly that. It gives us the freedom. So here we can see the same setup that we have in our code. And yeah, so this just makes it a lot easier to work with DynamoDB and its internal data structure. So here we can also see some of the queries that we can use. So some of them would be like the put item. Alright, so we have something like the put command, and we can see, for example, the put command has the put input and the put output. And if we click on this page, it takes us to a bit of a more detailed definition of how this works. So yeah, let's dive into the code and we play around with some of these functions. Okay, so in order to create a book, we are currently only getting a title and we want to add this to DynamoDB. So how do we do this? First of all, we have this .db client, and on this DB client we have a function called send, and this send needs to take in a command from AWS, and from the AWS package we can import a few commands. So let's call this, what do we need to provide it here? What's the short command? So let's just call it command. So we're going to create a command up here, and this command is going to be of type new put command, and it will import from the DynamoDB lib. It will import this new put command, and this new put command takes in a few properties. Okay, and then we will take this command and we'll pass it to the send function. And because this returns a promise, we need to await this. And now we need to define this command. So what do we want this command to be? Well, we need to provide it a table name, and we know our table name is books table, and we need to provide it with an actual item, and this item will be some object that defines our book, so the item that we want to add. And let's actually create that up here. So we can say our book item is equal to this object, and we will set our item here equals to this book item. Okay, So now we have that set up. In order to create this book will need a primary key or a partition key, and it will need a SK for the sort key. And this will be strings. So let's just add strings in it for now. And then we want to give this book a title. And where do we get the title? Well, from the book data that's passed into the function, we can get the title. So now we need to understand how do we want to create these primary and secondary keys. In order to search in DynamoDB, you have to always provide the partition key, and then the sort key can be used to do a bunch of different functions for contains or is between this and yeah, just a bunch of fancy other operations we can do on the sort key. So I'm going to create this book like this. We're going to have a partition key of book. So everything will all the books will basically have this partition key, and in the sort key we will specify something that might need to be searchable for this book. So we're going to create the book, and then we're going to add some UUID in here, and we need to now add this string template literal, and we want to add some UUID. So let's import the UUID package. So import v4 as UUID from UUID. Okay, and it's complaining that we don't have these types installed, so let's quickly do that. Yarn add okay. Now we should be okay. And this will generate the book sort key with some UUID. So we are able to search all the books, or we can search for a specific book where this property exists and there is some UUID that follows to make an exact match on our primary key. So this is getting quite technical with regards to how DynamoDB works, and I do not want to go into it for this video series. So if you're interested in wanting to learn more about DynamoDB, leave a comment and we can make that happen. Okay, so here we have a basic book that's ready to be created. Let's actually go ahead and deploy this function, which is the create books function, but we also have this new create DynamoDB client, but we don't need to deploy the whole stack. We can only deploy this one function. So how do we do that? We can say SLS deploy function with the F flag and then the function name, which is create book. So if we run this and wait, now it should go ahead and push the new code with the updated SDK to Lambda. So let's actually take a look at that code. So here I'm back in my AWS console, and what I'm going to do is I'm going to head over to the Lambda service. I'm going to click on my application of the book API, and I'm going to have a look at create book Lambda function. I want to take a look at this code. So here we can see the app, the handlers, and we have the create book. Under here, under this handler, we see a bunch of hard to read JavaScript, but one thing I want to search for is the create DynamoDB client, DB client. Okay, so here we can see that it has imported this code, so we now are going to be able to use the DynamoDB SDK to interact with the table. But first, let's view the logs. So let's set up a terminal to actually view this log. So SLS logs of the function create book, and we want to tail it. Okay, and then what we're going to do is we're gonna actually try and go ahead and create a book. So I'm gonna go to our endpoints here, and I'm pretty sure this URL has changed. So let me go and fetch what the new URL is. So API gateway, this is the new endpoint. Okay, it has not changed. Cool. So we have not removed and redeployed it yet, which I believe is the case. So we can now say post to books, and we want to send a body, and in this body we'll have a title, and we call this test1. Okay, and let's send. And we can see there's an error, something went wrong, please check your logs. And here the logs pop up telling us exactly what is wrong. Create book handler error, access denied exception. So this user is not authorized to perform DynamoDB put items on resource this DynamoDB books table. So because no identity-based policy allows the DynamoDB put item action. So this is quite a mouthful, and if you were to Google it, and you'd probably see this error of access denied come up quite a lot when you're working with AWS. So basically what this means is our Lambda function, this book repository that is part of the create Lambda function handler. So this create book, this Lambda function, which gets created and mentioned all the way up here. This Lambda function does not have the privileges to make a put request to DynamoDB. So how do we solve this? Well, we can add IIM roles to a specific function alone, but because all of these functions are going to interact with my DynamoDB table, I can again add a default up here. So how would this look? So I'm gonna again paste some of it in here. So we're gonna have under the timeout or anywhere in there, we're gonna add a new field called IIM with the role, with the statement, and then we have this object which has a bunch of other properties. And here we are going to say allow resource to connect to any resource, which you can refine to only this DynamoDB resource. But for now, I'm mentioning all the resources. And then we specify some of the types of commands we want to do in order to finish up our API. So we're going to want to be able to do queries. We want to do the put item. So that is the one that we currently got blocked for. And we want to be able to update. We want to be able to get the item. And then we want to be able to delete the item. So I'm going to save this now. And now I need to do a full SLS deploy again, because I made changes to the root. I need to deploy this whole service again. So that's as easy as just calling SLS deploy again. This will go ahead and set up the IIM roles, which will allow us to actually call these different functions, this put command. So once this is done, we can try again. Okay, so the deployment was successful. So now if we head back and open up our SLS logs for the function create books or create book, and we tail that stream, and we go back here and we now do a send call, we actually get back the data which is still being returned here. We can see when we actually create this book for the send command, we are still returning this like hard-coded data, but we do not see any error being thrown. So that means we successfully added it to DynamoDB. So let's actually take a look if that is the case. So we're going to go into the console, and then we're going to search for DynamoDB. We're going to go to our tables, our books table, and we're going to inspect our items, start the scan. We see we have one item. So let's explore the items in the table. And here we can see we have a PK of value book. Let's actually go into the property itself like this. So here we can see we have a partition key of book, and we have a sort key of book hash, and then some UUID. And we use hashes usually to make different parts of the string searchable and start grouping stuff this way. And then we can add as much properties, because it's a NoSQL database, we can add as much properties here as we want. For now, we only have title and test1. So this is the title that we submitted all the way from our API up here, and it created this book, which is awesome, right? So now let's actually go ahead and do the get for book. So now that we've created the book, we want to be able to get a book. So again, let's actually return the book that we just created up here. We don't want the PK and the SK to be returned this way. So let's go ahead and define the book ID up here as UUID, and then just add in the book ID like this, so that when we return, we can return the book ID with the title. So you can also get the book that was created back, but we don't want this SK and PK to be leaked in that way to the front end. We just want the front end or the consumers of the API to worry about one ID. Okay, so now we should be able to deploy that, and it should return not the hard-coded values anymore, but we'll do that after we get a book by ID. So how do we get a book? So again, we need to interact with the database, and this is quite easy. We're going to create a command again, and this will be a get command. And we can see how a get command looks. Once again, we need a table name, and we will probably move this table name to some environment variable that can be changed all the way from here. Okay, so then we need to search based on a key. So this primary key that gets formed based on the partition key and the sort key, this is like the main idea behind DynamoDB. And as soon as you get comfortable with modeling stuff this way, and it's quite efficient and very useful. So first we need the PK, and we want the PK and the SK to match exactly. So the PK is very easy because that's just the word book. And the SK is pretty much where we have this unique identification added to make this key as a whole unique, because we have a SK with the value of book with a hash and then some book ID. So that's where we can now add in this book ID that we receive from the function, and this will pretty much be it. Now we can do this await again, so we can say await this.db client.send, and we send it this command. And now what do we get back in response? We get a get object output. And if we take a look at how this looks, we get metadata, consumed capacity units, and an item that might be undefined. And we can see that this returns a book or undefined. So here we can then take this item, and if it is there, we return it. If it is not there, we return. So if it is there, then we return it like this, else we return undefined. I'm probably sure there's a cleaner way to do this instead of doing a ternary. But here we want to now return the res.item.sk. And the reason we take the sk value is because that's where we get the ID. So in order to get that ID, we're just going to replace the part of the string that has book hash, and we're going to replace that with the empty string. So it's basically just going to leave us with the ID. So then we have the ID, and the title will be the res.item.title, which is the property that we added in here. Okay, so this should give us a book by ID. We can remove that. And if there's no item found, it just returns undefined. And then we can get all books, and this is also pretty easy with the key setup that we have. So here we're not going to do a get command, but we're going to do a query command, because we're going to query for a bunch of books, not only for one. So the get command only returns one item. You can see it says item, and you'll see now if we do the query command, and this has a table name called books table. And we provided some key condition. So how do these key conditions look? So this is a bit of key condition expressions. And this is a bit of DynamoDB type syntax to help search for things. So we want to search where the pk value is equal to some placeholder pk that we will define with the expression attributes value. So here we can create this pk. So we're prefixing it with these colons just to make it a bit clearer, and this is the standard of doing it. So the pk should be books or just book, and the sk should match some value. So we are going to add an and here. So we have the and the sk should begin with the book hash. So we can group other things below the book as well, but here we can say begins with sk, and we add the placeholder. So this is almost like giving it some search function within the condition expression, and we want the sk to begin with this type of setup, right? What is the query command complaining about? I think this got imported from the wrong one. Yep, we need to import it from the lib. Okay, now we have this command. Now we again send this to the const arrays equals await this dot db client dot send, and we send it the command, and this returns a bunch of other stuff, but one of them is items, and items is either undefined or it's an array of records, which are our books. So I'm going to return it this way. So because our function will always return an array, I'm going to return the arrays.items, and if it's undefined or null, we just return an empty array. So this type of records, type of as book or undefined. Okay, so now we get books. We want to be able to delete a book, so let's do that part as well. So we again create a command, which is new delete command, and for the delete command we need to specify probably the table again, books table, and the key to exactly match. So again we can say the primary key should be just book, and the secondary key should be book, and then we can place in the book ID. Okay, this way that looks set up, and we can return nothing here, but we can await this db client and send this delete command. Okay, so there we go with the delete, and now for the update we can pretty much do the same we did for the create. So I'm going to copy this. We can actually, yeah, let's copy that. We're not going to recreate the ID though, so we're not going to do this part again. We're going to create the book item, which has this ID and this ID, and we set the new title, and then we want to put this, and if it already exists it would kind of just override it, but we want to use the update command for this instead. Okay, so the update command, let's take a look over here, and this is going to have a bit of a different syntax as well. We're going to use the update command, which has the key, what do we want to update exactly, and this will be again the pk and the sk, where the sk should match this ID, and the pk should just be book. Okay, and what is the new values that we want to update? So we can say expression attribute values, and the values that we want to update is the title at this point. That's the only thing we have. So we can say body data dot title should be equal to that, and we can say update expression, So here again is a long string that we can have different methods. That's helpful, but we can just say the title should be equal to whatever this title placeholder is up here, and this will update the book. So we can return this book item at the end here, or we actually again don't want that setup, so we actually don't need that, and we can just return the new setup like this. Okay, so I think this covers all of the interaction with the database. So let's go ahead and deploy this. So I'm going to close this logs, and I'm going to say SLS deploy. Okay, so with that deployment done, now if we try these out and we actually create a new book, so let's call it test2, and we create this one, we get a response back, and let's actually copy these IDs for a second. Okay, I'm just going to paste it in a new tab here, and let's create a new one, 3, and we copy this ID as well, and let's create another one, 4. Okay, so we have created 3 new ones, so let's go ahead and get all of the books. Okay, again, because we are sending a body along, let's get all the books. Okay, so that took a while, but now the consecutive requests are much quicker. But here we can see all the books that we have. 2, 1, 3, 4 with their different IDs. And we are returning them incorrectly. We can see we are returning them with the PK and the SK, and this is not something we want. But let's actually use an ID and get a book by ID. Here we can see that it now returns the ID in the correct fashion. So we will be able to update the get by or get books very quickly. So we can go to that function, get book by ID, get books. Here we only return the items directly, but we want to return a book. So we first would need to map this. So we can say books is equal to the res.items. And if there is nothing, just add it like this. But else we want to map through them. So each item, we want to return an object that is of type as book, and this will be one with an ID, so we can say item.sk dot replace, just like we did previously, the book field or the book string with the hash with just the empty string, and then the title will just be the item.title. So here we have done some JavaScript logic just to work with the data. And if we just want to return this function, we can say SLS deploy function -f and then the function name, which is get books. And this deployment actually happens quite quick. And there you go, it's done. So now if I were to do a get call for all of the books again, so I'm going to remove this ID and I'm just going to make a get call. We can now see it doesn't return the PK and the SK, it only returns the ID. So there we have it. We have API, so we haven't tested the update yet, so let's actually do that. I'm going to update this one. I'm going to give it a new body or just a new title. Updated new title. And we can send this. And it returns back the newly updated one. If we duplicate this call, so I don't need to go back the whole time, open in a new tab, and here I'm gonna go all the way back to just the get all books, and I remove this body again and send. Now we should see this one was updated with the new title. And if I were to try and update another one, let's go to this endpoint definition, update new title number 2 and send, and do a get call, we can see that that was updated. Okay, so now let's try the delete. I just want to delete this one. Let's delete it. Okay, it's deleted. If we search for it now, we only get back 3. And let's go ahead and delete all of them. Okay, deleted. And we do a search again. Okay, deleted, and we go there. Okay, so there we have our basic CRUD operations set up with DynamoDB and AWS Lambda and API Gateway. And we use the serverless framework to set this up. So yeah, I hope you found this helpful. And then next we will continue to add uploads. So we can now upload videos or files or images or any type of asset and connect that to a book. So let's do that next. Okay, so let's now add a S3 bucket. So we're going to use this S3 bucket to upload our images and have our hosted images there. So we don't need our own server with a volume. We can just use S3. So we need to set up a S3 bucket as a resource type. So let's actually first go to the documentation. Okay, so here I am at the AWS S3 bucket CloudFormation, and here it gives us again the properties that we can set. And if you take a look, pretty much none of these properties are required. You literally just need to set up a bucket with a resource with a type of AWS S3 bucket. But we are going to set a few other properties as well. So feel free to come and look at what those properties do in detail at this page. Okay, so back in the code, we are going to create a new resource and we're going to call it the main bucket. And this will be of type AWS S3 bucket. And the properties that we want to set, you can see it doesn't provide any default properties because by default it doesn't require any other properties. So we can run SLS deploy now and it would create a S3 bucket for us. So this is a pretty simple resource, but we're going to give this bucket a specific name. And the idea with S3 buckets is they need to be unique for the region that they are in. So we are currently in the EU Central 1 region, so the bucket name should be unique for everybody, not just for your own account. So try and get some unique names. So I'm going to choose my full stack junkie domain as a prefix, and then I'm just going to describe what this bucket is. It's the book API bucket. So you can probably add your name with like some random characters in front with the same name and it should work. And if you're in the same region, obviously. If you're not, then yeah, basically it just needs to be unique. Okay, so let's actually just add these properties to describe the bucket, and then we go ahead and deploy. So I'm going to call SLS deploy, and let's actually go ahead and see what it does. So I'm going to head over back to the dashboard, and I'm going to take a look at our current buckets. So if I refresh here, I can see we only have the development serverless bucket that deploys the code and the CloudFormation. We don't have a bucket yet. There we see a bucket. Okay, so we have the FSJ book API bucket. So this is the one that we declared in here. Okay, and this is not even completely deployed yet, but this bucket resource part of the step was obviously already done. So if I take a look at this bucket, we can see there's no objects in there. We can view some of the properties, and some of these permissions we will be setting through the serverless framework and the CloudFormation for the bucket. Here we can view some metrics, management, and access points. So let's actually set up two more important parts of this bucket so that we are able to generate pre-signed URLs. I'm actually gonna wait on that, and let's let's create the endpoint or the Lambda function that would go ahead and generate this pre-signed URL for us. So I'm going to call this Lambda function generate pre-signed URL, and this will have a handler which would go to app handlers, and let's call it generate pre-signed URL handler, and the handler function that gets exported. Now I just want to use this as example. We have a description, and this would basically generate upload URL for S3 bucket. Okay, and the event that would trigger this would also be a HTTP event, and the path would be generate pre-signed URL. The method would be a get request because we just want to get, and the CORS and the privacy flags we don't need to worry about now. Okay, so here we have this definition of a function. Now let's go ahead and actually create this handler. Okay, so now we have this handler. Let's create the class generate pre-signed URL handler, which will have a constructor, and let's export this asynchronous function called handler that receives the event, but we're not going to use that event. We'll have a try catch where we do some stuff. I'm going to actually copy from here. I'm going to copy this part and I'm going to paste it in. I'm just going to change this class definition instance to be the handler above. This handler will then receive not the book model instance, but we are going to create another client and then just inject the client directly into this handler. So we want a async function called process event, and we don't need to pass in the event because we're just going to respond with something. Okay, so there we have this. Let's change the error messages. Error generating pre-signed URL. Okay, so this will still be the same. And the constructor, what do we want to be dependency injected? Well, we're going to create a new handler, and this handler will allow us to talk to S3. So we'll call it the S3 client. And I'm just going to copy this over here because it will be pretty much similar, but it won't be a DynamoDB client. It would be the S3 client, and then we won't have this intermediary step. We can just export that down here. So now we need to install that SDK of the S3 client. So let's go ahead and do that. So I'm going to say yarn add the AWS SDK / client -S3. Okay, so now that is installed, we will need to install another package, and this would be the pre-sign URL package. So the S3 request pre-signer package. Okay, now that we have that, we can import this S3 client. S3 client. Let's remove this. Is it gonna pick it up? No. Okay, let's import it. Import S3 client from AWS S3. Okay, here we go. Now we need to import that S3 client, and we can say create S3 client. Are we not exporting this function? Oh, this is still not named correctly. S3 create S3 Okay, now we have this S3 client, which we should add to the constructor as well. Okay, so we need to inject that into the dependency. Okay, so now we can actually, in this S3 client, we can create the part that uploads, or we can generate the pre-signed URL. Okay, so what do we need to do here? First of all, we will need to create an upload key. So S3 saves files also with this key string type structure. So very similar to DynamoDB and Redis type, where you build your strings. So you can almost build directories with these. So I'm just going to create an uploads folder. You can almost see it as a folder. And then I'm going to give it a unique name for that file that's being uploaded. So I'm going to import from version 4 as UUID from the UUID package. Okay, so now we generate a unique upload key, and then we want to generate a command. So we can then again say put object command, and this put object command should be imported. Let's see from here, put object command, there we go. Okay, and then we need to provide some properties, the bucket name. So we called this bucket FSJ book API bucket, and then the key is this upload key that we've just created. So that's basically it, right? This is as simple as it is. We need to do a put to this bucket with this key, and if we provide the signing part of this logic, so this is where we use the other package, the get sign URL, which is also not being imported. Let me reload my VS Code. Sometimes that works. Here we go. So we have this function, and we need to await the response, which will be the pre-signed URL. And to this function, we need to then pass in our current S3 client. We need to pass in the command that was generated above, and then we have some options that we can set. So one is expires in, and we want to set the expiration date for this URL. So if it doesn't get used in 900 seconds, then it expires. That's 15 minutes. Okay, so we want to return with this API call a status code of 200 with a body of a JSON string that contains the image URL that will be saved to the database, and we will structure that now, and then the upload URL, which would ultimately upload, which would be used to upload the image. So this, we are sending this to the client already, so that the client can save this to the database, because this would be the actual URL, and I'll show you in a sec how do we get there. So let's maybe keep that out of it for now. Okay, so this is basically the logic of creating a pre-signed URL. So let's actually go ahead and deploy this and see what we get from there. So I'm going to say SLS deploy, and this should deploy this function, get pre-signed URL, which points to this handler. We do some injections here with a S3 client, then we use the get signed URL package to actually generate this pre-signed URL. We provided the client, the S3 client, our command and some other settings, and then we return with that upload URL. Okay, so once this is deployed, we should be able to make the following request. Okay, so here we can see the generate pre-signed URL function was created. So let's copy this endpoint, and I'm going to make a GET request to this endpoint. When we make this GET request to our pre-signed URL endpoint, we get a URL which we can now use to upload an image. So I'm just going to create a new tab. I'm going to paste in that endpoint. Be sure to make it a put request. And here we can see this endpoint pre-signed URL that we got back has a bunch of other stuff. The expiration date, some security token headers, what the ID we're making a put object request. And yes, you can do a few other checks with this pre-signed URL package that could make it more secure, only limited to specific sizes, etc. So let's actually go ahead and choose a file. In my binary data, I'm going to choose just some image, and I'm going to hit send, and we get this error access denied. So why are we getting this error access denied? And after some Googling and searching and figuring out, it came down to that this handler that's generating the pre-signed URL itself doesn't have access to actually do anything with S3. So we need to, under the IAM roles, add another action to allow S3 actions. So I'm just going to allow all S3 actions just to keep it simple, but you can refine this to specific S3 actions if you'd like. So now if I were to deploy this again with that small change of just adding a S3 allow rule, then it means that whenever this URL is generated, this URL actually has the privilege to do things with S3, in this case do a put of an object. So that was a quite tricky find, but that would be the idea, right? That this Lambda that creates this pre-signed URL actually has the rights to do this put command. And yeah, with this add, we could have just said put object, but at a later stage we want to be able to read as well. So yeah, we could probably refine it a bit better. Put object and S3 get object. But yeah, just gonna keep it like this for now. And this is probably all deployed. Yes, it is. So now let's try it again. I'm going to create a new pre-signed URL. I'm going to take this URL, make sure to copy it nicely, and I'm going to add it in here. And I'm just going to keep the same image, and I'm going to upload. And now we see we get a status code of 200 and there's no response. So now if I go to my S3 dashboard and I do a refresh here, we can now see there is actually files under upload. So I've uploaded an extra one as well during some testing. But yeah, here we've uploaded our image. And if we were to click on this URL link, we again see access denied. And you're like, okay, but shouldn't I be able to see this now? And this is another rule of S3. By default, S3 is closed to the public, so you can't access it. Okay, so by default, if we look at the permissions of a S3 bucket, we can see we block all public access, and there's no bucket policy that allows us to actually read objects from this bucket. So that are the two things that we still need to configure, and then we will be able to have bucket uploads. So let's go and do that. So back in the serverless file, under the resource of the main bucket, we need to add a new piece of property. And I'm just going to paste this in here. But basically, it's the public access blocking configuration. And we want to turn all of this to false to allow this bucket to be accessed publicly. And we can do that in the console as well by editing this and then just unselecting all of this and hitting save. But like I mentioned before, we should try and not do stuff in the console. We can use the console more of just validating what the console might be a bit more descriptive about stuff. Okay, so after we've added this part, we first need to deploy this before we can add the bucket policy, which is going to be another resource type, which is going to allow us to access objects publicly. So once this is deployed, we can go back and view that it has actually turned off all of these access block configurations. Okay, so that is deployed. Now let's go check that out. If I would to refresh here, we can see that on has turned to off. And if we edit this, we can see by default this are all toggled off now. Okay, but this still did not change the fact that I am not able to view my images. So if I were to go here and view, it still says access denied. So that's only the first part that we needed to do. I keep closing the tab. But yeah, that was the first part we needed to do, was to toggle that permissions on the bucket. These block all public access. Now we need to add a bucket policy to allow get objects. So let's do that in the code base. Okay, so let's actually add in a new resource type. So we're going to add a main bucket policy. Let's just call it main bucket policy. And this will be a type of AWS S3 bucket policy. And this will have properties, which will be the bucket name, which we have book API bucket. And then we have some policy statements that we need to add here. So we can add a statement, and this will effectively allow an effect with the principal of asterisk and the action of S3 get object. So we are allowing this get object, and the resource we are pointing to will be ARN, so we can get this resource details from the console. So here from the console under properties, we can see our prefix for the ARN. So we can copy that and paste in our ARN over here. And we should postfix it with a slash and the asterisk or wildcard. So now we can deploy this part, SLS deploy. Okay, so now that that is complete, now we can go look at our console. We can do a refresh over here and go under permissions. And now we can see this public access is toggled off, and we actually have a policy added here. And you can see that this statement and the syntax of the effect allow principal action, what action it is, and then what resource matches what we have in the code over here. So I'm hoping that this video series kind of just makes the journey into serverless and some of the AWS services a lot more clear and less overwhelming. So yeah, that's ultimately the goal. So now we should be able to access the objects. So if I go to the object and I view objects link, it should download the image. And if I view this image, there we can see this is the image that was uploaded. So now we actually have this URL over here, and this is the image URL that we're going to save in the database as well. So when we have this generate pre-signed URL, we want to respond with the image URL as well. But this image URL will have this format. So I copied it from from here. And basically we're just gonna add the key ourselves. So the upload key is that last part of the URL. So we just add our own upload key in there, and now we should return the actual uploaded URL of the image, and that can be saved to the database. So let's actually do that part to finish off this, like, let's say, MVP of our serverless project, where we've kind of learned a bunch of stuff, and in the rest of the videos we'll kind of start doing some more refactoring and discussing some other topics that might occur. And do some final quick refactoring. This is going to start in the create book, where we are going to update the fields that we want to save for this book. So first of all, we're going to have the thumbnail, which is just going to be of type string. Then we're going to have a description for the book, which will also be of type string. And for now, let's keep it simple. This would be the fields that would be required to send through the API. And this interface gets updated because it's inferred from the schema. We validate the body based on that schema. And then if we navigate all the way into create book, so here currently we're still not doing much, but I'm gonna clean this up. This was more an idea than it needs to work that way. But basically we can go into the create books here, and now we need to update the book item with the description, and we can say book data dot description. We can now add the thumbnail, which would be book data dot thumbnail. Okay, so just like this, and it should still save. Now we're still returning the book setup up here, but what I want to do is I want to say rest await this db send, and for this command we want to toggle the return value to all new. So now it would return on this res, it would return res.attributes, which would be the newly created book. But we don't want the pk and the sk, we only want the id. So we're going to need to create some mapper that we can reuse everywhere in this repository. So I'm going to create a private function called map to external type, and we get an internal type, which would be of type any for now, and it should return a type of book. And this type of book currently only wants a title. We can add a description in here, which is of type string, and we can add a thumbnail of type string. So this is just a bit of TypeScript typing, and there's definitely better ways to do this, but I'm just keeping it simple now. So we can say the internal type, we'll take the sk value and we'll remove the book hash string from that, and then we need a description, which we don't need to do any mapping for, and we have a thumbnail, which again we don't need to do any mapping for, and the title as well. So if there's specific mapping that needs to happen on a field, we can now do it in there. And now we can say this dot map to external type, and we have exactly what we need for that. To get a book by ID, we want to do the same thing. We're no longer going to return it this way. We're going to map to external type, and then we're just going to add the res.item. And then when we get books, this would be the same idea. We do the mapping right here, map to external type, and we pass in the item. Just like that. So this makes it a bit more clean. And when we delete, we don't return anything. And when we update, we now want to be able to not just only update the title, but the thumbnail, which would be the book data.thumbnail, as well as we want to update the description. Okay, so we can say book data.description, and now we would need to update this update expression. In this update expression, we will use commas, And then the next one, we don't need to say set again, but we can say description will be equal to the property of description, and then a comma again, and then the thumbnail will be equal to the thumbnail property. Okay, so this is the update that we needed to do there. And we also want to return the new updated values, so all new values, which means we can get the response from this send event, and then do the same thing where we send map to external type, and we send in the res.attributes. Okay, so with this, if the attributes were to be undefined, because it is an update, it's possible that it is not found, we should return undefined if this property is actually also undefined. Okay, so with that done, I believe we've done most of the refactoring. The last part I want to refactor is by adding this book table name, which is used all the way in here. I want to replace it with an environment variable or constant variable at the top. So we can say const book table, and this will be equal to process.env.book table. So in order to get this process.env loaded, we need to add under the provider, we need to add an environment property, and here we can specify book table, which we named according to our resource. It is book table, just like this. So now we should be able to get book table over here. I'm just going to cast it to a string for sure, and then we can deploy this again. So let's go ahead and do that. So SLS deploy. So now that that part is deployed, let's go ahead and test this out. So I set up some endpoints to just make these calls a bit easier. So let's do a get all books endpoint, and let's see what we get. There are no books. So when we want to create a book now, we don't need the publish field. We only need the title, the thumbnail, and the description. So here I have a thumbnail that's already uploaded. So I use the pre-signed URL. So we can try this again. We get a pre-signed URL as well as an image URL that is not saved yet, but as soon as we run this command and choose an icon, so let's go to documents, downloads, let's choose this icon and send, we see a status code of 200. Now we can copy this URL because that image is uploaded to that URL, and now we can add it as the thumbnails URL, and now we should be able to run this, and we get an internal server error. So what do we do here? We go check the logs, SLS logs for the function create book, and let's tail it to see what is happening. Okay, so it's streaming the logs now. Let's go ahead and run this again. Something went wrong. Let's see. So I'm going to keep these errors in as well, so that we can see sometimes stuff doesn't go according to plan, and it's always easy to debug them. So validation expression, create book handler, validation express returns can only be all old or none. Okay, so when you do a create, so if we go to the book repository and we do a create book here, we unfortunately cannot return the all new. So this can only be set to none or all old. But let's try the all old one. I don't think that's going to work. I don't think it's actually going to return the information that we need. So we can play around with that, but for now what I'm going to do is, because this book item is the same one that we are adding to the database, I am going to instead provide this function with the book item. So we don't need this response anymore, we just need to await. And let's deploy this again. So I'm going to open a new terminal. I'm going to say sls deploy, and I only want to deploy the function that we edited now to make it quick, which is the create book. So this deploy should be almost instantaneous. So there we can see it's done. Now if I go ahead and try this out again, I'm just going to clear the listen terminal. Let's go ahead and create this book. And we get back a status 200 with a success. So now if I were to get all books, we should get back one book. And we can try out the rest of the endpoints as well. So let's go ahead and try the get book by ID. So here we only have one book currently. So we can use that ID and just add that ID in here. I have a path parameter for book ID, and we send, and we get back the book, and it's formatted accordingly. And then we can take a look at the update book by ID. So again, we need to provide the same ID and what values we need to update. So we first need to provide all the values that are set on the book already, and then we can override whatever ones are changing. So I'm just going to paste that in here. So let's say we want to change the description to this is the updated description of the book, and the title we can just say book 1 and then updated. And if you wanted to upload a new thumbnail, you would do again generate a pretty sound URL, upload that file, and then take the image URL of the new thumbnail and place that in here. But we're not going to do that part because that's already tested. And let's update this quickly. And we can see this is the updated description of the book. And if we want to get this book by ID again, we actually do see all the fields were updated. So the last thing we need to test is the delete book by ID. So let's add this ID in here. I'm just going to go to my clipboard history, add in this ID and send. And this isn't a get request, it should be a delete. Okay, and we try this out. And we see the message deleted. So now if we wanted to get all books, there's no more books anymore. Okay, so this is the first introduction basics to using Serverless Framework and AWS, and some of the basic services like AWS Lambda, API Gateway, DynamoDB, and S3. So I hope you found this video series useful, and if you did, remember to like and subscribe, and then I will see you in the next one.